Hello everyone, and thank you for joining us for today's webinar, Process Mining with RapidMiner. I'm Haley Matisow, and I'll be your moderator for today's session. We're joined today by Rolf Klinkenberg, co-founder and head of data science research here at RapidMiner. Rolf is a data scientist and consultant with more than 20 years of experience in data mining and predictive analytics. We'll get started in just a few minutes, but first a few housekeeping items for those on the line. Today's webinar is being recorded, and you'll receive a link to the on-demand version via email within 1 to 2 business days. You're free to share that link with colleagues who are not able to attend today's live session. Second, if you have any trouble with audio or video today, your best bet is to try logging out and logging back in, which should resolve the issue in most cases. Finally, we'll have a question and answer session at the end of today's presentation. Please feel free to ask questions at any time via the questions panel on the right-hand side of your screen. We'll leave time at the end to get to everyone's questions. I'll now go ahead and pass it over to Rolf.
Welcome to the RapidMiner webinar on process mining, and thank you, Healy, for the nice introduction. So today's webinar will start with a very short introduction into RapidMiner, and then give you an overview of process mining, what are the different tasks in process mining that we want to address today, and then we dive into a live demonstration. So let's get started with introducing RapidMiner. Our focus is on making real data science fast and simple. With real data science, we mean not just superficial analysis, but really diving deep, getting the real insight and getting the leverage from the most advanced machine learning algorithms. Making it fast and simple means from your idea to your implementation should just be a few clicks. It should be easy to do. So we have a very visual approach to that, and you will see that in the live demonstration. So our focus is to make you and your teams more productive and to empower as many people as possible to use what we call real data science. RapidMiner is the #1 open source data science platform. We have more than 200,000 registered users in our active community, and it's also #1 marketplace for finding experts or for finding extensions to the software. So we have more than 250 global clients, more than 50 channel partners, so we have a presence all over the globe. Analysts view us also quite positively. Gartner has ranked us as one of the leaders in the Magic Quadrant for data science platforms 4 years in a row. Forrester's also seeing us as a leader for the second time already this year. KD Nuggets, the major platform for data mining experts, performs a poll every year in May, which are the data mining tools used by the experts, and you can find RapidMiner there as a #1 visual integrated open source data mining platform. And if you're an R or Python user, you don't have to be sorry or sad, because you can seamlessly integrate Python, R, and a lot of other tools into RapidMiner and use it all from within the same graphical user interface. There's a few other nice things we achieved, like we were innovation winner awarded by Howard Dresner and some other awards. So let's now dive into what a typical data mining process looks like and how a unified data science platform like RapidMiner can support you in that. Usually when you want to analyze data, obviously you have to start with the data. It can come from various sources. It can be flat files like Excel sheets or CSV files, maybe standard SQL databases or no SQL databases, maybe emails, web pages, maybe sensor measurements, maybe Twitter feeds or other social media input, maybe text documents like PDF documents or, as I mentioned, web pages. And now it's nice to have one platform that allows you to ingest all this data from the various sources, to join it as needed, to clean it up. For example, if there's missing values, noise, or any other errors you want to clean up. And then you can do the actual modeling using machine learning. We have more than 200 different machine learning algorithms available. Generating a model alone isn't good enough because you have to know that you can rely on this model. So you have to know how robust it is and how well it will perform on new, previously unseen data. So validation is also critical. We offer a range of validation schemes, including, for example, cross-validation, sliding window validation for data streams, etc. So once you validated your model and you know it's reliable enough, then you can actually operationalize it. It means you can embed it, for example, into web services to make it available for other IT systems upon demand. You can integrate it into web apps using the RapidMiner server. You can have it automatically executed periodically using the scheduler of the RapidMiner server. And so RapidMiner covers the whole range from ingesting data from all types of sources, preparing and transforming it as needed, modeling, validation, to the deployment. And that deployment can be the automation, or it could be integration in other tools like your preferred visualization tools like Tableau or ClickDeck or Cognos or any other. It offers also its own web apps if you prefer to do that. And you can also generate alert emails or exports as you need them. So the whole process from start to end is actually covered. Now let's take a look at process mining. What is it good for? What is it about? A very typical application domain is financial audits. If you want to know if an organization is compliant to the regulations and to maybe its own rules, then it can be helpful to analyze the traces of the processes being performed by that organization. So for example, if you have, let's say, a bank, and you have processes that involve customers, for example, applications for credit cards, then the customers typically leave a digital trail. When they contact you through the web page, there is some log of your web server. There's probably a log also on your customer relationship management system and so on. So in today's world, there's a lot of traces of interactions in the company and with the outside world. And obviously these traces, often in the form of log files, can be used to analyze if everything is going on in the way it should be, if it's compliant to the rules. It can be used for operational audits if you want to know how efficient your operations are, if there's any bottlenecks or time thieves in your processes, if there's potential for optimization. It's very helpful for analyzing transactional systems and services. Can be used, for example, in mergers and acquisitions, can be used for analyzing financial transactions, for organizational transactions. Could also be used for emails, of course. Then another field of application is IT audits. Obviously IT systems are easier to analyze because they always have the digital traces. And it can be very interesting to see that if you provide IT services and you want to make sure everything is used the right way, there's no security issues, there's no intrusions, there's no performance issues, so you can check the system compliance, you can check the performance, and you can do IT forensic analysis also if you want to analyze things that went wrong, either in terms of performance decreases or in terms of intrusions or other issues. Another very interesting domain is manufacturing. If you have a manufacturing plant, you typically have a lot of machines there, you have a lot of assembly stations, you have a lot of products going through, and if you look at that, let's say you have a factory plant with 100 machines and there's thousands of products going through every day, then it may be hard on first sight if you just look at a log file to answer questions like what are my downtimes, where are my time thieves, where are my bottlenecks, how efficient is my process, is everything going like planned, or are there workarounds going on. The typical log files are so huge that you can't see anything with your bare eyes, so you have to kind of find a way to aggregate the information to extract the meaningful information. And process mining is a very helpful tool because it allows you to take the log information, the process picture, so to say, that you see in real life, extract a process model from it, compare it to your ideal model if you have any, or to find bottlenecks in that. And we will see that in detail later on. So manufacturing as well as business process, they leave their digital footprint, and that's what we're going to analyze. So steps typically include collecting the digital traces, the logs, normalizing them so we can compare them across systems, for example, using timestamps, correlating things. For example, if I see that something in one system is happening, is it correlated to something happening in another system, and to do various kinds of analysis. Some of those we will see later. So what I will show in the live demo is the RapidMiner Studio, the desktop version of RapidMiner and its visual interface, plus an extension you can download from the marketplace, which is called RapidProM, and it seamlessly integrates the open source tool ProM, which is the leading tool for process mining. This is an example of how such a task could look like. Let's say you have a manufacturing process or a business process where you start with a certain task. For example, let's say it's the credit card applicant coming to the bank. So he enters the office, and now the task is, for example, take down his address and customer information. If it's a machine, it might be a log. Okay, the machine receives product A, at that time performs certain steps and then says, okay, steps completed. And whatever it is, it will be recorded, in this case in a log file A from application A. Then the next step is the information is passed on to another department or to another machine in the production line, again processed, and then I have another log file information. And then maybe I perform a check. If it's a product in my manufacturing line, maybe I want to check if the quality achieved in that step was good enough. And if the test says, let's say the test is something like, is there a quality issue? And if the test says, yes, there's a quality issue, maybe I have to perform task 3A, return to step 2, do that again, and check again. And I have a loop doing that until I'm satisfied with the quality. Then I can proceed to task 3B, perform that, and then so on for task 4 and 5. I get different log files. I want to integrate the information, merge the information, and I could, for example, use the timestamp information and the customer ID or the product ID or the machine ID to connect the information. Once I have it connected, and then I can use that for documenting my processes, for automatically extracting the process model that is behind the real-world process that I observe. I can use it for optimizing the process model by finding bottlenecks, time thieves, and other issues or bypasses that I don't want to have, and then trying to change the model that I use in my production system. So let's now switch to the live demonstration. When you start RapidMiner, it looks like something like this. You have a start screen where you can choose what you want to do. We have some tutorials you can work with. You can start a new process. If you have a data mining task that others have solved to you before, we may already have an application template ready for that. I'll show you that a little bit later. But for now, let's start with a blank screen to just give you an idea what RapidMiner looks like in terms of the user interface. So if you have a blank screen, that means in the center of the tool, you will design your data mining process. And that could start by, for example, dragging in some data. Just use some sample data here. Connecting it so that I can see some output. And I could press the play button. The system would then run, show me the data table. Could have done the same with a double click on the data set. And now I can see I have a data set with one ID column that identifies each line of data. I have a so-called label, that's my target variable. It's a classification of the data rows into 3 different categories. In this case, it's 3 types of flowers. I can see that in the summary view, the statistics. If I click here on the label, I can see it's 3 different labels, Iris, setosa, versicolor, and virginica, each of them having 50 cases in my data set. And the task now is to check if I can use the 4 numeric variables, which are some measurements of that plant, to predict which type of iris color, flower I'm actually seeing. Obviously, humans are not so good at looking at large tables and finding the pattern. What can help is visualization. We offer all types of charts, like 2- and 3-dimensional and so on, that you can use to visualize the plot and the data set. Don't want to dive too deep here. What you, for example, can see here, each data line is represented as one line, each attribute as one column, so that you can see that some attributes are not so helpful for separating the data, while others, like here A3 and A4, are more helpful. If you take a standard scatter plot, you could switch to the corresponding dimensions now, and you would see that the dimensions A3 and A4 are quite good separators. The blue cases, the torsi is easy to separate because they're much smaller, and also the red and the green cases can be separated quite well in those dimensions. Just to give you a quick idea for loading and visualizing data, now let's see, you want to do a first machine learning model. You can see that we have a lot of them available. We have operators for data access from all types of sources, data cleaning, modeling. For example, if you see I want to do predictive modeling, maybe decision tree, I can just go here. Alternatively, you can just type tree here and it will also bring you there. Just drag and drop it over here. It's automatically inserted. Press the play button and I can already see the result. I can zoom in a little bit by using the scroll wheel on my mouse, so by using the buttons here. And you can see that A3 was also found to be the most predictive variable by this learning algorithm. put on top of the decision tree. So my first question would be when I see a new data item, what's the measurement of A3? If it's smaller than this value, I'll predict iris setosa. If it's larger, I have to ask another question. If it's larger than that, if it's Virginica, etc. You can see that the colors represent the classes, and if a leaf of the tree has only one color, it means it's perfectly classified on the training data. If a leaf has mixed colors, it means that it's not perfectly classified. Like here, you see that this particular leaf covers 48 training cases. 47 of them are vesicular in green, but there's one red case, Virginica, that will be misclassified by that tree. But that means just in this case, the tree only misclassifies one training case, so that's quite good. It's an easy example just to get you started. So one option is you start from scratch like we just did, and use what RapidMiner is offering to basically build your own process. If you're solving a problem somebody has solved before already, for example, like direct marketing campaign optimization, customer churn modeling and prevention, or credit risk modeling, etc., then you just click on the template. Let's click on predictive maintenance as an example, predicting machine failures before they happen. You can see that somebody already designed the data mining process for you. Now you can play with it. You can adjust it to your needs. Let's just take a quick look by running the process and stopping it here after loading the data so we can take a quick look. It's a data set about machine measurements, so we have the machine ID to know which machine we're looking at. We have an indication whether this particular machine failed or not. And then we have a range of sensor measurement that hopefully provide us information to predict such a failure. While looking at the data as a human, it's difficult. You can look at charts, but with more than 20 variables, that means more than 20 dimensions, it gets a bit difficult. So I could look at the same kind of chart I looked at before. Still looks a bit messy because I have more data points now. But I could look at the average per category, then it becomes much clearer. So this would help to find that the sensors in the upper range are not so helpful. They're not distinguishing the classes, but in the lower range I do see some differences on average, and maybe there's some chance for a model to pick it up. But we don't want to find the model manually. We let the system do that. So you can see here is an optimizer. Inside the optimizer is a so-called k-nearest neighbor in this case, and the optimizer then optimizes the parameter value k. We also have a sub-process that finds the best features for predicting the target variable, the label, and then show me that ranking. So let's just continue the process to see the results. Or maybe let's go back 1 second. I forgot to mention, we also load in a new data set where we don't know the classification yet. And then to this new data set, we apply the model that the learner has delivered to score the new cases to predict whether there will be a machine failure or not. And that's what we see here. Failure predictions and also sorted by confidence. So for the ones at the top, the system thinks there's a high risk of failure. If you go down to the bottom, there will be very small confidence values for failure. I said there was also an optimization for different values of k for the k-nearest neighbor learner. I have the predictive accuracy listed here. If I sort by the accuracy, I can see that on this particular example set, I can obtain a 70% accuracy on unseen cases. That's not too bad depending on the problem. Some problems you can achieve higher accuracies, on others you're happy if you achieve that. Then we have the ranking of the strongest indicators. You can have that as a table or as a chart. I usually prefer the chart. I'm a visual person. So let's look at that as well. And now you can see what are the most important variables, those that give you the strongest indication of whether the machine will fail or not. In this case, sensor 7, 6, 8, 5, etc. Okay, this was a very quick introduction into the graphical user interface and different ways how you can use it. But the focus today is process mining, so let's focus on that now. I prepared three little demos representing 3 different use cases. The first being process discovery. So let's do a double click here to load the process. So we import some event log data. In this particular case, it's in the XES format. That's an XML-based format to describe process logs. And we pass this to different algorithms. They're all available in the process mining extension. So I have it already on my machine. If you don't have it on your machine, it's very easy to install. You just click on the menu extensions where it says Marketplace, Updates and Extensions. And then you say, I want to do process mining. So you search for something that's related to process. Now my RapidMiner Studio connects to the server. And when it search the database of all available RapidMiner extensions on the marketplace, then I can select which one actually I wanted to look at. Who's contributing? Obviously RapidMiner is publishing extensions, but also third parties, other companies, universities. And in this particular case, the Rapid Pro M extension, you can see here, you just click on that, select it for installation. I already have it installed, so I cannot select it anymore. But all you have to do then is click here, confirm the open source license, and you're done with the installation. Maybe you have to restart RapidMiner once so it can leverage that. And that's all you have to do. This was developed by the Technical University of Eindhoven in the Netherlands. They're expert on process mining, and there's also developers of the open source Pro M tool. So now we have that functionality seamlessly available in RapidMiner. If you go to extensions under the operators are these little functional boxes that we have in RapidMiner. We call them operators. And if you check for the Rapid Pro M here, you can see that this extension adds 58 operators to RapidMiner, different functions for analysis, for conformance checking, for conversions of models, like for example from a PetriNet model to a business process model notation. It has discovery algorithms that are machine learning algorithms that take a log file and generalize that into a business or general process model. We'll see that I have already added some, like here, for example, the alpha miner. If you want to add that, all you have to do is drag and drop, connect the process data, connect it to an output, and that's all you have to do. Since I've already done it, let me remove it again. Then there's also export and import operators, which are obviously relevant if you want to import your log file or other data, or maybe in a pre-existing model. And obviously you want to be able also to export models and log files. And there's also other operators for handling your log files. If you do experiments on testing the robustness of methods, maybe you want to add some random noise, or maybe you want to do some other manipulations with your log file. And there's some more utilities also available. So that's all in the functional toolbox. To save some time and to show you more, to be able to show you more, I prepared some processes. You don't have to do all the clicking live. We import the log file data. We pass the same data with this multiplier to different learning algorithms. For example, we just start the process. One of them being the alpha miner generating PetriNets, which is a very common format for presenting process models. Another one is an ILP learner, also generating PetriNets. Some heuristic learner, some inductive miner, social network analyst learner, transition learner, and also what's called a fuzzy miner. So there's different algorithms that are also described in the literature. And now we are curious, we want to see the results for all of them. That's why I built a process that basically invokes all of the learners. In a typical application, you probably would be happy with one, maybe just the alpha miner or whichever is your preference. But if you want to evaluate them and get a feeling for what the type of model and quality they deliver, then it might be interesting to test just a whole bunch of them. So here you can see a typical process model. It's describing the whole data set. Maybe a few words on the data set before we dive into the models. We look at a data set from an Italian municipality, a city that has a database of all the processes involved in collecting traffic fines, like for speeding and illegal parking and stuff like that. And they have it from initiating the process up to the collection of the money. So now you can see the overview. If I want to be able to read it, I have to zoom in a bit. So let's do the zooming and let's take a look. So this process starts, according to the log files, with something called create fine. So that's the initial event I see in 100% of the cases. Then in 2/3 of the cases, obviously the offenders pay immediately. So obviously the policeman or whoever is writing the ticket is live at the scene when the person is there, and they can ask them to pay the ticket immediately. So that's the easy case, obviously. If they're not present, let's say the car is parked in the wrong place and the driver is not there, what you typically do is you write a ticket and then you would send it by mail. So that's in the other cases. And then if someone has paid the fine, you would insert that into your information system so that you could say penalty payment is complete. Or maybe it's not, someone is not paying, someone is appealing and well, claiming that he shouldn't pay the fine, and then maybe that even goes to court, the prefecture. And then maybe there is some result of that appeal, the offender needs to be notified, and at some point maybe I also need to collect the fine. So there's different things that can happen. The thickness of the arrow indicates in how many cases which thing is happening. So there are some rare cases that lead to some bypass. This model doesn't show me too much detail of those bypasses, but they're giving me a first impression. There's obviously different algorithms producing different models. So here's the next one. If we zoom in again so that we can read it, you see it starts obviously with the create fine action, and then one option was the appeal. It's an arrow that's not the widest. Luckily not everybody does appeal, and you can see that the stronger arrows go down to some other states, like when somebody paid, I can already insert the fine as completed, or in the case that there is some appeal, then I would go towards the appeal. Different modeling algorithm and also a different presentation of the results. But imagine the original log file in this case had several 100,000 log file entries, several 100,000 fines and process steps. That's very hard for a human to understand what the underlying process is if they don't know it already, and what the non-compliant items are in this log file. So this is really helpful to understand the underlying process. This is another view of it, looking at something like a social network analysis. You can choose different layouts to see the connectivity of the items. For this particular application, I think it's not the most helpful one, so I don't want to spend too much time on this particular graph set. Just wanted to show you that there's a lot available depending on the task that you're looking at. What I think is more helpful in some cases maybe a tree. In this case not a decision tree, but rather a tree that helps you to see the sequences that can occur starting from a particular process item. Also you can visualize that again as a flow with different states and connections from the flows. So look at that here. You can see again another visualization. The axes are also showing a little number there. That's in this case a number of cases that you have along this particular transition. For example, from create fine to send fine is complete, and so on. And you can see that some of them are grayed out a bit because they occur much less frequently. So in most cases you complete the penalty process when the payment was received, and only in few cases there is an appeal to a judge or some other issue, and then that would be visible here. Knowing that, I could now go back to the log file and, for example, try to filter out the appeals to see what actually is happening there. Why are there appeals anyway? Another type of visualization is so-called transition graphs. So I see different transitions that can be observed. In this particular data set, this is not so helpful. Here's another example. This is a PetriNet generated by the RapidMiner. I like that because it's very readable. It shows me the major states, like create a fine, then what can happen, like I send it out to the person that committed the thing. If they pay, then I can insert that. If they appeal, then obviously the appeal process kicks in, and I have maybe to do an extra loop with send appeal and notify of the result, etc. of course, you can also zoom in this particular view. So this was an example, or it was different learner as examples, how I can actually generate a process model given a log file. That is task one. Given the log file, show me what's the underlying process. So even if I don't know what the designer of that process had in mind, I can take the real life log file data and just extract the process model. Not the one that was in the head of the designer, but the one that's really happening in the organization, which can be very interesting. So if, for example, if you have a complex manufacturing hall and you don't see how the goods are flowing from which assembly station to which other one, you could actually analyze it using that. Or if you have your office or your administration and you don't actually see how information objects or documents or tasks are flowing through the organization, if you have the digital traces, you can actually visualize that, and if you can see if that are maybe unnecessarily complex processes going on, etc. And the next step, and you actually want to go one step further. You want to know, now I've seen my process model, and I see additional log file data, and this process model that I start with, it could either be one that I generated from the data of the past, or it could be one that I manually generated in a modeling tool. Either way, now I have a new log file data, and I want to compare that to the model. So since I didn't want to design a model manually, I just load the log file again, create a model automatically using the inductive learner. It generates a Petri net. But as I said before, you could have also generated it manually. In that case, you would use an operator called import Petri net and feed it in here. Same thing. And then this conformance checking now goes ahead and checks the log file entries and how much they conform to the model that is provided to this operator. So let's do that. Reload the data. It's running right now. Well, as I said, it's several hundred thousand lines of log files, so it takes a while to load. Now the model generation is happening. It goes through all the lines of the log files and tries to generalize that into the model. Now the conformance checker takes the model, compares the new log file entries, or in this case, it's just a copy of them, and then it'll show me the results in a moment. And what you can see here, trace fitness, you see in this particular case, I have a very high conformance. 99% of my traces conform to my model. In this case, it's not a surprise because I'm using the same data set for training the model and for testing it. So that probably in the real world wouldn't make too much sense. You'd rather take, for example, the log files from the production when it runs nicely and smoothly, generate your model, this is how it should be, and then you keep on feeding the new log that's going on, and then you would realize if something is going different, if suddenly your employees are doing different things, or if something unusual is happening. And now if you go to the next tab in the results, you can see we have the Petri net model, similar to what we saw before, but now we also have some highlighting going on. So we see actually while the data is mainly flowing and some more unusual things. So again, we can zoom in. And you have things going on. Okay, someone has something like create and complete fine in one step. Okay, interesting. And then there's sometimes split happening. Insert fine if it goes to appeal, for example. Or if you receive the payment, then it's much easier, payment received, and then you would just follow the arrow, and that should take you to more or less the completion of the overall process. If necessary, there will be a credit collection, but if it's already paid, this is not necessary. So you will see that there's two options. You can go through the collection process, but if it's already paid, or if the appeal court decided that there's no payment is necessary, then you would skip the payment, directly go to the final state of the process model. So you can see the strengths. How often do I see these things? Are they compliant to what my model actually foresaw as a path in the graph? And then you can also see things that are not so compliant to that. So that is checking compliance. Might be interesting for audits to see if everyone in the organization behaves like they should, if the process definitions are followed, or if people do different processes. And maybe if someone doesn't follow the process and does something else, it could be something bad, maybe some fraud is going on, or it could be something that makes the organization less efficient. But actually it can also be something positive. Maybe someone has found a much more efficient way to get things done. And now I can look at how is he doing it, or she, and then I can maybe decide to change my whole process and make this seemingly unusual behavior the norm because it's more efficient. So it's actually a lot of potential there, not only for hunting down the bad guys, but also for finding opportunities. The next step is I have my log file data and I want to analyze, again, given a certain process model or a model generated from the data, either way works again. I want to analyze the process in terms of how much time does the object, maybe the customer or the business object, spend at a particular step in the process. Are there time sieves in my process? Are there bottlenecks? Maybe in my manufacturing production line, are there stations where I have too many products that have to go through and the machine cannot handle it fast enough? That would be something I can detect here. And then I could, for example, to decide, okay, if I add another production station here, I probably can have a reduction of the waiting times and so on. So that helps you to optimize the process or the overall setup of the manufacturing or whatever you're looking at in the organization. So let's start the process again, reading the log files, passing it on to the model generation. I will deliver once more a PetroNet model for looking at the process represented by the log files. And then once we have both the log file data and the model, then we can analyze the performance looking at all the instances that I observe, for example, all the customers or all the products going through my process. What are their times, like how long do they need at each step and overall. And then I can add that information to the PetroNet model in the visualization. And that I think is one of the most helpful graphs in the whole demonstration from my point of view. So I have to tell the system, how do I measure the time, or how do I measure the performance? And obviously timestamps is what the system suggests to use as a variable. And yeah, I pick that particular data column because that's exactly what I want to have. Now I can also answer another question. Do I only want to see the synchronous moves, or am I also interested in being a bit more relaxed? So for example, yeah, let me see a few more results, so I'll choose that option. And now it's analyzing the performance according to my preference and checking the timing at each step of the process. And yeah, in a moment will also allow me to visualize that. So now the visualization is being generated, so the actual computation has already happened. And now we can see the result. So yeah, similar PetroNet. Now you can see we have some added color, like there's something red going on there. There's some orange and yeah, some white stuff. The white and the blue stuff is not so critical, but I'm just saying that you don't have to believe me. Let's take a closer look. Let's start in the beginning, maybe zoom in a bit more so it's more readable. So we start again with creating the fine object, and then yeah, one option is to send that fine out to the person who committed the thing that caused the traffic fine. And then there's different things that can happen. Obviously, one thing that can happen is someone sends an appeal. And you can see here that typically takes 9.3 months on average. That's quite a long time. The payment complete, if it's without the appeal, is much faster. It's typically 2.3 months. So, and then if someone directly pays, the processing is much faster. It's roughly 2 weeks. So you can see that different things cause different problems, or that certain passes are preferable, obviously, from the money collection point of view. You can see here also if there's an appeal and the judge completes that, I lose another 6 months here if I'm unlucky. Yeah, And then there was this very red box, so I'm a bit curious what's actually going on there. And yeah, that's if the money collection hasn't worked so far and they have to basically have the credit collection kick in, then I see that it takes on average of 20 months. That may be because people cannot pay and I just have to wait until they can pay again, but maybe their address has changed and it's harder to get the money from them because I first have to find out where they moved. I don't know what the reasons are. I don't live in this particular Italian city, and but I just see this is obviously quite a time sieve, 20 months delay just for this particular step. Obviously, you can use all kinds of log data for that. So now I use some publicly available traffic fine data, which is kind of a benchmark for process analysis and process mining. But you can use, for example, your IT log files, or you could use your business process log files, or you could use your financial transaction log files, and you could see if things follow certain processes or not, if they're diverting passes, and how many items or objects are going the non-standard way, and then dive in a bit deeper as to why that is actually happening. So I hope that gave you some insight in what's possible with process mining. Obviously, 45 minutes for the overall webinar, including your question and answer session that we will start in a moment. Don't allow to show everything, but I hope you got some idea of what can be done. You can start with the log file data, generate a process model. You can do then the compliance checking for audits or for finding things that are unusual, either in a positive or a negative way. And you can also use the performance analysis then to see where is my process inefficient, where is time being lost, where are maybe products waiting in the production line, or where are customers waiting for their requests to be processed. And so where's the potential for improvement or for optimization? And that's probably the main purpose. If not the audit by itself and the compliance analysis is the purpose, then it usually is the optimization, understanding the process, finding the issues, and then having an idea what to fix. If you want to try it for yourself, you can download RapidMiner from rapidminer.com. We have a big community of more than 200,000 registered users that are also happy to exchange information, exchange experience, know-how, so you can actually learn a lot from there. Of course, you can also reach out to us, and now it's time for question and answers, and I'll hand it over to Hilly again for the moderation. Thanks a lot for your attention.
So great, thanks Rolf. So a reminder to those in the audience, we will be sending a recording of today's presentation within the next few business days via email, and we'll send that to the email that you registered with. So it looks like we already have a bunch of questions that have come in. Ralph, I do have a couple questions around the log file that came in while you were doing your presentation, so I'll ask that now. These guys are asking, what does the log file look like? What format is it in? And do you have to clean it before you do this process? Rolf, it looks like you might be on mute right now.
I'm sorry, yes, I was muted. So I decided to just show you the particular log file for the road traffic fines that we just saw before. In this case, it's a particular XML format, and each event is represented by a certain, you could say, object in the log in this particular log file. So XML is one possible format. If you look at RapidMiner, obviously RapidMiner offers a lot of data import operators. So if you go to data access, if you have another format, maybe you have some type of CSV file, that would be also something you could pull in. And you can configure that according to what kind of file format you have. Similarly, so there would be one option also to look at CSV files. Another option is maybe other XML formats. Another option are databases. So let's close that tab, open this one. So there's many different data sources that the data can come from. When I showed you the operators available in the Rapid Pro M extension, you saw that there are also some utilities and transformation functions. And the question, do you have to clean up? That depends a bit on what learning method you're using. Some learning methods are more robust to missing values, like the decision tree, for example, we saw in the beginning. That particular learner can handle missing values, but for other algorithms it might be different. Some of them cannot do that, and if you do standard data mining, the easy way to handle missing values is just search for missing in the operator search box, and you'll see a lot of different operators that can help you to handle missing values. So for example, to replace missing values, maybe by zeros, maybe by the average, or by some other value, or to use a machine learning method to actually learn to predict the missing values from the other values that are not missing. There's different options that you can do. You could also maybe think about interpolation for numeric values in a time series or so, or you could think about filtering. You say, well, if something is missing, I don't want to manipulate the data too much, let's just kick it out. For process mining, it may be a bit complicated because if you kick out some steps of the process, obviously your trace becomes incomplete. So in case of process mining, I would think twice before kicking stuff out. And if you kick it out, you should kick out the complete trace for a particular object, not just for one step. So in that case, you would use a filter on the object ID. So filters are also available. Filter examples is for filtering data rows. So if you find that certain IDs, certain object IDs should be removed, you could use this particular operator for that. And yeah, that would allow you to clean up your log file or your database and proceed with the learning if the algorithm doesn't handle the missing data, but some do, obviously. If you want to know if a learner handles missing data or not, let's just check it. I mentioned the tree. There's actually a nice way of checking it. Let's just drag and drop the tree in here. You click on the tree, you press the F1 button for, well, kind of help on the operator, and you can see an overview of what it can do and what it cannot do. For example, the decision tree can handle polynomial attributes, that is nominal attributes that have more than 2 possible values. It can also handle binomial, they have just 2 possible values. It can handle numeric ones, can handle simple classification with just 2 labels, binomial label, or with more than 2 labels called polynomial label. It cannot do regression, so it cannot handle a numeric label, but other learners can. It needs labeled data for training, so if you have unlabeled cases, don't feed them into the training, just into the application of the tree, and so on. And you can see the little checkbox at the bottom right, the green check, missing values. So decision trees are robust, they can handle missing values. You also have a description there if you want to learn more about the decision tree algorithm, its parameters, and how it works. There's a lot of information there describing also all the parameters, and there's also a link for an example process. Just some information on the site. So I hope that answers the question. So there is ways to load data from different sources. There's ways to clean up data, for example, in case of missing values.
Great, thanks, Rolf. Lots more questions coming in here. I'll ask you the next one. So engineering designers
There's
in the building
question,
industry.
can we share the data set? Yes, we can. It's a publicly available data set. I suggest we create a zip file that includes the data set and the 3 process mining processes that I've shown in the demo. And then whoever is interested should reach out to us or reach out to you. That's something that our coordinators have to make sure. Then we can send you the data set and the processes.
Great, that's actually a good point to point out. So yeah, we can go ahead and bundle that and send that out to you guys
see a long list of
here on the line.
Okay, there's a few with hyperemesis.
Ralph, I'm going to ask you the next question here. So engineering designers in the building industry typically generate CAD drawings from different
There's one
disciplines.
question on support vector machines and support vector machine regression. Support vector machines, for those who don't know it yet, is a particular machine learning algorithm. We have several implementations of them available, and if you look at a support vector regression, one of the question was, can the support vector machine that we provide do regression? Well, let me do again the F1 trick, and I see numeric label works. Missing values is something support vector machines don't like, so you would have to clean the values first, but it can do numeric labels without a problem, and it can do binomial labels as well, so 2-class classifications. So yes, we do support vector machines, and we can also do regression with them.
Ralph, I have another question here for you that you might be able to address.
Okay, there's a question regarding whether I have to explicitly specify the related fields in the XML file. So that depends a bit on the kind of analysis you want to do. So here first all I have to do is to specify the data file, like where is it coming from, to load it in. But there was one analysis when we look at the performance, then you need to tell the system what is actually the timestamp, because the system needs to understand what what the measurement of time is. Otherwise, how should it tell how long a particular thing spans there? For the XML formats, there is some information in the XML, obviously, that can be leveraged. And this XES format is a standard log file format. To be honest, I'm not such an expert in log file formats. I've just used the ones available to me. But I'm pretty sure that there's options to use other ones in the tool. And so, okay.
Ralph, are you still there?
Hopefully
No
I can
worries.
hear you again. Somehow my speaker was turned off. Sorry for that.
Can you hear me now?
Yes, I can hear you now.
Great. There was one question that I wanted to address that I don't think you were able to hear me, but can process mining be used for quality management for each discipline? So this person is saying in engineering designers, they typically generate CAD drawings from different disciplines. Can process mining be used for quality management for each discipline?
Yes. And there's different ways how you can do that. One way would be you integrate the quality information into your process log. So for example, if you have process states for something like quality defect or quality check successful, not successful, or for different kind of quality issues, then that would be represented in the process flow model, and I would see the passes that lead to these quality defects. That's one way of looking at it. The other way of looking at it is you have the process mining that we saw today seamlessly integrated into RapidMiner. RapidMiner offers you a lot of other data mining functionality. So you could now actually take the same data, analyze it with other types of algorithms. For example, use a support vector machine or a decision tree or some other learner to learn a target variable that you choose. So for example, you could say the quality variable is your variable that you want to learn, the system to learn, and then the system could automatically detect what are the key influence factors. So it's similar to the predictive maintenance example we did in the beginning. You could define another target variable that would be not the failure of the machine, but maybe the quality grade. Like is a quality factor is okay, or maybe it's a numeric measurement of that. And then you can look what are the indicators of that. So in that case, that would be the causes maybe, or the things that let me recognize the quality issues. And there could, of course, also be a model depending on what I put in here. If I want to understand what's leading to the model, or I can recognize it, I could just drag and drop a decision tree in here and rerun the whole process. And then I would also see a decision tree model. So the nice thing about RapidMiner and these operators, these little boxes, is you can just drag and drop additional stuff in there if you want to see additional types of information. And if you want to change your target variable, you just need one little box to do so. So you use this so-called set role. And now I could go into this operator and tell the system which attribute I would like to use as my target. So maybe instead of predicting whether the machine will fail or not, I want to try to predict the value of sensor 10 given the other sensors. So all I have to do is to tell the system, this is your label now. And then this would be the new task. So if you have information in your data that describes the quality, then you could obviously learn something about the quality and how it relates to your sensor measurements, to your process parameters, or to which machine you use for the production, and so on.
Thanks, Ralph. A couple more questions I want to address. This person's asking, what is the pricing model for, I believe it's for the extension.
Can you say that again? I didn't get it.
So this person is asking, what is the pricing model for the extension?
Oh, okay.
So is it paid or is it a free extension?
This particular extension is free. You can download it. All you have to do is go to the marketplace and you can get it for free. The marketplace is quite a nice place because a lot of universities and a lot of companies provide extensions to the software for all types of problems, and a lot of those extensions are freely available. And there are also some where you get a basic version free and you have to pay for a more advanced version, but most of them are actually non-commercial. That means you can download them, you can use them, and you can also use them for commercial purposes, but you don't have to pay for them. And RapidProM and the underlying ProM tool, both are open source tools under the Affero GNU public license, so you can use them for free for commercial purposes also. If you want to build your own product on top of it, you have to obviously respect the license there, but yeah, for deploying it, no problem.
Great, thanks. Another question here, does this application, or is it able to understand sales transaction type data as well?
You mean self-transaction data was in the same entity? Or I didn't get the question completely, sorry.
Yeah, so they're asking, can you use process mining for sales transaction data?
Sales
I know
transactions.
you gave your example was different than that.
Yes, of course, yes. Sorry, I didn't understand the word properly. So yeah, you can use sales data from maybe your web shop, for example. You can see what was the path that the visitor was going through my web page and when did he make the purchase. Or if you have a tracking in a physical store, obviously you would also have a log of the positions, like where is the customer moving, what is he doing. I know that a very well-known Swedish furniture store sometimes does that. When you go shopping there might be a person following you with a little notebook and pen and just taking a record, not of who you are because it's anonymous, but just how you go through the store, what are you looking at, what are you doing, and then they obviously also will digitize that and analyze that to see what are the typical traces of how people are moving through their store. So you can do it in physical stores, but you can also do it on web stores. And that might give you some clues. If they have to take extra long ways to get to their purchase, maybe you can optimize the web store to shortcut, to basically recommend the right thing earlier on. And then we come to something else. What we do now is process mining, but if you think a bit further, maybe you want to do some recommendations. So there's some recommender engine extension on the marketplace also. If you want to build a recommender system, then you could maybe add something to your web shop that helps to generate shortcuts for your customers, because from the traces you can learn what people really want and then maybe recommend it earlier on. That would be one option. And you can see also how to optimize the overall structure of your web store.
Great, thanks. That was a good explanation. So it looks like we're just about time here. So we had a lot of questions come in. If we weren't able to address your question here on the line, we'll make sure to follow up with you via email within the next few business days. So thanks again, Ralph, and thanks everyone for joining us for today's presentation, and I hope everyone has a great day.